Today, I would like for you to consider the average value of a function. While it is straightforward to calculate once you know how to integrate, it is a common application that you are bound to calculate many times. Visually, imagine a curve defined on some interval a to b. At some value c, the area under the curve and the area under the value of the function at c will be equal on the given interval. To find the average value of a function, you take the definite integral from a to b and divide by the length of the interval b minus a. For example, let's find the average value of a function. Let's take f of x equals 8x to the third minus 4x, and let's find the average value on the interval 2 to 5. Using our formula, we will need to integrate our function f from 2 to 5 and divide by the length of the interval 3. Using our basic integrating techniques, the antiderivative of 8x to the third minus 4x is 2x to the fourth minus 2x squared. Using the fundamental theorem of calculus, we evaluate the antiderivative at 5 and at 2 and take the difference. Finally, we divide by the difference of 5 and 2, giving us our average value of our function, 392. At this point in your mathematical journey, you will now be familiar with different averages you can calculate. Being able to decipher which way to find an average will be very important. For a quick check of understanding, try to match the following prompts with their appropriate mathematical statements on the right. Given the function g of x equals sine of 2x, match the average rate of change of g of x over the interval negative pi over 12 to pi over 6, match the average value of g of x over the interval negative pi over 12 to pi over 6, match the average of the values of g of x at the endpoints negative pi over 12 and pi over 6. Take a moment to pair up the statement and the calculation. We will start with the average value. You will notice from the three mathematical statements, only one has an integral. The average value will always go with an integral. The average rate of change is the function evaluated at the endpoints over the length of the interval. You will notice that goes with sine of pi over 3 minus sine of negative pi over 6 over pi over 6 plus pi over 12. And finally, the average of the values is just summing two values and dividing by 2 given our last statement. Let's now try two more calculations. First, find the average value of some function. We'll say f of x equals e to the negative x plus 4 over the interval natural log of 2 to natural log of 8. First, you're going to integrate f of x. We're going to use substitution. Let's say that u equals negative x. Then du will equal negative dx. We're now going to integrate e to the u plus 4 with respect to u, which we will get e to the u plus 4. Using our fundamental theorem of calculus, our integral simplifies to 3/8 plus 4 times the natural log of 8 minus the natural log of 2. Remember to use our log properties. We will simplify this to 3/8 plus 4 times the natural log of 4. We divide by the length of the interval, so we will do the natural log of 8 minus the natural log of 2. Again, using our log properties, our exact answer will look like 3/8 plus 4 times the natural log of 4, all divided by the natural log of 4. Next, we will find the average value of another function. Let's say h of x equals x plus 1 over x. And this time, let's use the interval 3 to 9. To integrate h of x, divide x plus 1 by x. We are now taking the integral of 1 plus 1 over x. The antiderivative of this is x plus the natural log of x. Using the fundamental theorem of calculus, we will substitute in 9 and 3. And if you use your log properties correctly, you will be left with 6 plus the natural log of 3. Now, don't forget, we are finding the average value of the function, so we need to divide this by the length of the interval. So we will be dividing by 9 minus 3, or 6, giving us our exact answer of 1 plus 1/6 times the natural log of 3. Finally, when it comes to testing our understanding of the average value of a function, we must be prepared to parse the context of a problem to know when to use the formula for the average value versus other averages, like the average rate of change of a function. We want to make sure we practice reading calculus problems, so let's wrap up our work on the average value of a function with a multi-part problem. You are welcome to use a calculator. The rate at which a tank is filled with liquid, measured in liters per hour, can be modeled by the function r of t equals 8 e to the t plus 2 cosine of 3t minus 6t for our time between 0 and 15, where time is measured in hours. Part A. To the nearest whole number, how much liquid fills the tank over the 15-hour period? Part B. What is the average rate at which the tank is filled over the time interval 5 to 10? Part C. What is the average rate of change at which the tank is filled over the time interval 5 to 10? You can find explanations and solutions linked in the description below. Thanks for considering. We'll see you in the next one.